Hello, Dr. Marston, and thank you for taking a look at our video. We investigated the impact of variables on energy loss from water. We began by identifying our variables and creating a design matrix using a 2K fractional factorial design of 1/4 fraction and assigning high and low settings for each. Once we constructed our design matrix and decided on our variables, we built our experimentation box, which was made out of a styrofoam cooler. Inside of that cooler, we controlled the air circulation, the cup lid, ambient temperature, volume of water used, and light, as well as the spin vane. Our response was measured through a thermocouple, which was placed inside of the styrofoam cup. So you can see the temperature probes pulling information here onto my computer through this USB cable. This USB cable is attached to the Arduino, and the Arduino is attached to a breadboard which has some stuff that we wired up for this experiment. The light is in the top of the lid there in the form of an LED, and the two temperature probes, which are measuring ambient conditions as well as the cup, are running into the side. On the opposite side here is the fan, which is being powered by a constant voltage DC power supply. On the inside of the lid, we have a light sensor, which is measuring the light intensity, and a light emitter, which is supplying the light for that variable. On that side of the box, we have a fan, which supplies circulating air in some of the trials. And this is the ambient temperature sensor. It is held in suspension above the ice and away from the wall. This is the temperature sensor that is measuring the temperature of the water in the cup. It's our response variable or response temperature sensor. The cup is sitting inside of a plastic container which keeps the ice off of the walls of the cup to better simulate just a cold environment rather than ice surrounding the cup as if it was in a cooler. Inside there we have the spin vane, which is also another parameter which we control through a constant RPM. We can see here the system running in one of our trials. The power supply is powering the fan, which is circulating the air inside the lid. When Chris takes off the lid here, we can see inside we have the spin vane running, lid off, we have cold ambient conditions, and then we have our temperature probe measure. You can see here all of our trials and repeats of 9-second temperature measurements at 1-second intervals. And if you squint closely here, you can see our two repeats with 16 trials each. Each trial is comprised of a 9-second collection window where we collected temperature at 1-second intervals. Our two repeats had pretty closely resembling slopes of temperature loss, which we were pretty happy with. Once we had our slopes, it was just a matter of finding the averages of our two repeats, and what you can see here is a result of all of our experiments. With the table filled in for our average response against our different parameters at high and low settings. Our effect summary is as follows and was built in JUMP. The cup lid was clearly the most significant factor, and if we used a confidence interval of 95%, then the volume would also be a statistically significant variable. And in conclusion, the lid being on the cup as well as the volume of the liquid inside of the cup make the biggest differences. So this summer, if you want to reduce your heat loss from your cup, then be sure to keep a lid on it and fill it up to the top. Thank you.